In this lecture, we are going to discuss about the discovery of neutron. It was James Chadwick who in 1932 discovered the last particle of an atom, and it was known as neutron. Before the discovery of neutron, J.J. Thomson and as well as Goldstein discovered the proton and as well as electrons by using cathode rays tube experiment. Interesting fact to note here is that James Chadwick used alpha particle scattering method or alpha particle scattering experiment to discover the neutron. Dear student, in order to understand the discovery of neutron, you need to understand the pre-existing model of atom before the discovery of neutron. In 1804, it was John Dalton who gave his Dalton atomic theory. According to Dalton atomic theory, matter is made up of small particles, and these particles are smallest and indivisible. They cannot be created and destroyed, and he gave the name to these particles atoms. The word atom is basically a Greek word. It is drawn from a Greek word atomus, which means unbreakable. So according to Dalton, atom is unbreakable smallest particle of matter. However, in 1836, it was J.J. Thomson who proposed Thomson atomic model. And according to J.J. Thomson, atom is made up of other smaller particles. Atom is not a smallest particle. It has also another small particle, and that particle is negatively charged, and J.J. Thomson gave name to that particle electrons. According to J.J. Thomson, atom has a positive charge and it is uniformly distributed, whereas electron are negatively charged. They are particle and they are present inside the atom, just like a plum in a pudding. Both the positive and negative charges cancel out the effect of each other, and due to this, the charge on an atom is neutral. However, this model was further modified due to discovery of proton by Goldstein and on the basis of that, Rutherford proposed his model in 19. And according to Rutherford, atom has a center, and a center of an atom is known as nucleus. Nucleus of an atom is consists of positively charged particles, and these particles are known as protons. Most of the space of an atom is empty, and electrons reside around the nucleus of an atom. So now there was a specific reason. On the basis of that reason of the Rutherford atomic model, James Chadwick discovered the neutrons. Question here was that there were basically two questions. So now let us discuss that how from the Rutherford atomic model scientists believe that there is a possibility of another third particle inside the nucleus of an atom. So dear student, according to Rutherford, atom consists of a nucleus, and nucleus is positively charged particles. So now, as you know that according to basic physics, two same charges repel each other. Same charges repels, whereas opposite charges attract. So now if the nucleus of an atom has a positive charge, plus charge, or and plus charge, so these are same charges, so these charges will repel each other. So it is not possible for a nucleus, if it has a positive charge, to remain stable. So this was the first reason. Due to this, scientists believe that there is a possibility of another charged particle known as neutron, which basically bind which basically bind the proton inside the nucleus. So neutron was basically, scientists believe that there is a possibility of third particle and it's act like a bonding particle inside a nucleus of an atom. Second reason of discovery of neutron was quite simple. So according to, as you know, that helium atom according to helium atom has atomic number 2, and whereas its atomic mass is 4. However, according to Rutherford, atom has only proton in a nucleus. So if atom has a proton in a nucleus, then the atom will the mass of the helium atomic number of helium will be 2, and as well as atomic mass of helium will be also 2. So this will be atomic mass of helium. Whereas according to Rutherford, atom has a proton and electron. So for hydrogen atom, the atomic number of hydrogen will be 1, whereas it has no neutron, so atomic mass of hydrogen atom is also 1. Okay, so now if we considered the Thomson atomic model, then the two hydrogen atoms must be the mass of two hydrogen atom must be equal to the mass of one helium atoms. ठीक है? To the mass of one helium atom. However, since you know that according to Rutherford atomic model, helium has only 2 protons, and as well as helium has 2 protons, and as well as helium has 2 electrons. So this means that atomic weight of the helium is just 2 according to the Rutherford, and whereas the hydrogen has one electron and one proton, so the atomic weight of hydrogen is 1. So according to Rutherford, two hydrogen atom mass or weight must be equal to one helium atom weight. However, scientists observed that the weight of helium atom He 2 in plus 4 is greater than two hydrogen atoms. This means that there are some additional particles, and due to this the atomic weight of helium is 4, and there are some additional particles which are basically causing incorporation of increase in weight of an helium atom. So these new particles could be possibly neutrons. That's the reason due to which the neutron were discovered. First reason of discovery of neutron was that nucleus of an atom has positive charge. These positive charge are not possible to be bonded because they have same charge. They must repel each other. So there could be, or there may be, another particle which is causing the bonding of a nucleus positive charges, and that particle is known as neutron. And second reason was that the atomic weight of an element was different According to Rutherford, atomic weight of helium it must be 2. However, in actually the atomic weight of helium is 4, so it is more. And this is an indication that the increase in a weight of a helium could be possibly due to additional charge or neutral particle. So he called, or he gave name to that particle as a neutron. So now, dear student, these two were the basic reason on the basis of which James Chadwick discovered the neutrons. So now let us discuss about the experimental setup James Chadwick used for the discovery of neutrons. Dear student, James Chadwick in 1932 discovered the neutron by using alpha particle scattering experiment or by using artificial radioactivity. Student, please keep in mind that there are two types of radioactivity. One type of radioactivity is known as natural radioactivity. Second type of radioactivity is known as artificial radioactivity. So now what is the difference between natural radioactivity and as well as artificial radioactivity? In natural radioactivity, an unstable nuclei is converted into two or more stable daughter nuclei. Whereas in artificial radioactivity, and stable nuclei is made unstable by interaction of energy or by interaction of charged particle. So James Chadwick used the phenomenon of artificial radioactivity for the discovery of neutron. The experimental setup of James Chadwick was based on alpha particle source. Alpha particles are the particle, basically they are helium nuclei. So James Chadwick used alpha particle source. Alpha particle source usually lead, polonium, etc. are basically polonium etc. are used as a source for generation of alpha particle. Basically, these are radioactive elements. So radioactive element were used to generate alpha particle. Alpha particles are helium nuclei, He2 plus 4. So nuclei, they give 2 electrons, so there will be plus 2 charge on them. They are helium nuclei. So the James Chadwick incident these alpha particles on beryllium foil. Beryllium foil was made up of very tiny. It was very tiny foil. It may be composed of very few atom of beryllium. So beryllium foil. James Chadwick incident alpha particle on the beryllium file, and whereas on the back of the beryllium file there was a paraffin wax, or there was a material which was proton sufficient or with more protons. So same material which was basically film or wax was basically used, which is basically paraffin wax. Paraffin wax was used for the sufficient because of the sufficiency of the proton in them. Since you know that paraffin has a carbon and hydrogen bonded together, so it has a carbon hydrogen bonding. This means that paraffin has more hydrogen, so this means that paraffin is proton rich. So proton rich paraffin wax was used by James Chadwick. You can use normal wax and also pepper for the production of the proton. However, in James Chadwick experiment, James Chadwick used the paraffin wax for the uh, due to more amount, yeah, due to the additional amount of the proton on the paraffin wax, or due to more hydrogen atoms on the paraffin wax. So now, uh, James Chadwick basically incident. James Chadwick basically incident alpha particle from alpha particle source on beryllium foil. Okay, like this, these alpha rays were basically incident on the beryllium foil. Alpha particles or alpha rays. So when alpha rays were incident on the beryllium foil, James Chadwick noticed that there were radiation produced after the incidence of the alpha particle on beryllium foil, and suppose the nature of the rays were not known. Suppose these rays are ray 1. So in this way, continuously new radiations were basically produced from the beryllium source, from the beryllium foil, and they just fall on the paraffin wax. So now, when the ray 1 fall on the paraffin wax, James Chadwick observed that paraffin wax, there were some radiation produced by the paraffin wax, like this. And suppose that these are ray 2, and these rays were detected by a detector present just behind the paraffin wax. And according to the detector, the rays produced by a paraffin wax after the interaction of rays 1, he called them that these are protons. So now this means that if the detector is detecting the proton, this means that in paraffin wax, the ray 1 when incident on the paraffin wax is it just ejected the hydrogen in a form of ion which were detected on the detector. It doesn't eject, or it don't eject the carbon atoms in the form of ion. Why? This is the basic question, that why when the ray 1 fall on a paraffin wax, why it doesn't eject the carbon but it ejects the hydrogen? Reason is quite simple, student. As you know that alpha particle in the form of ion, they have atomic number 2, and whereas they are 2 electron deficient, whereas beryllium atom Be has 4, atomic number is 4, and the atomic mass is 9, which is basically less than the mass of the carbon atom, whose atomic number is 6, and whereas atomic mass is 12. This means that hydrogen atom, only hydrogen atom has only hydrogen atom has a less mass as compared to the carbon, beryllium, and helium. This means that hydrogen atoms, these hydrogen atoms in the form of ion, will be released from paraffin wax, and they will be detected by the detector. So now, how we can say that the ray 1 is a neutron, or uh, their mass is equal to the mass of proton. We can say this on the basis of law of conservation of momentum. According to law of conservation of momentum, total amount of the momentum remain conserved. Initial momentum must be equal to the final momentum. So initially, ray 1 is basically is absorbed in a paraffin wax. Its transfer total of its energy to the paraffin wax. This energy is transferred into the hydrogen atoms and convert them into hydrogen ion or proton, which were detected by the detector. This means that the ray 1 is totally absorbed in paraffin wax. That this means that the mass, the momentum uh, of ray 1 P1 is equal to the momentum of the ray 2, which means mass of ray 1 or particle of 1 of ray 1 is equal to the mass of ray 2, which means that mass of ray 1 is equal to mass of proton. So on the basis of this, James Chadwick concluded that the particle which were in the form of ray which were in the form of ray 1 are basically neutron, or they have same mass as a particle which were ejected from the paraffin wax, where paraffin wax was basically ejecting proton. So the mass of proton is equal to the mass of particle in array 1. Now, question here is that what is a charge on array 1? What is a charge on a particle on array 1? For this, James Chadwick performed experiment by using a charge plate. And when the ray 1 passed through positive and negative charge plate, James Chadwick detected that ray 1 has no deflection, which means that there is no charge on particles of ray 1. James Chadwick and again performed a second experiment in which he applied a magnetic field, and he observed that ray 1 has no deflection in the magnetic field. This was further validation or approval that ray 1 is neutral charge particle. Third experiment which James Chadwick performed was that he removed the paraffin wax in his whole experimental setup. When he removed the paraffin wax, ray 1 just directly fall on the detector, but detector did not detect any kind of radiation, which means that ray 1 is neutral. It is basically a charged particle known as neutron, which has basically no charge. It has zero charge. So with these experimental setup, basically, James Chadwick confirmed that there is third charged particle in an atom, and that third charged particle is known as neutron. So now, dear student, let us discuss what kind of chemical reaction, what kind of radio reaction, or how a radioactive reaction basically take place during the James Chadwick uh, experiment. So basically, artificial radioactivity. So according to James Chadwick, he basically took alpha particle source, and also in experimental setup he used beryllium atoms. Let me draw the schematic diagram of James Chadwick experiment first. Beryllium atoms, and behind the beryllium atom there was a paraffin wax, paraffin wax, and after that there was a detector. This was detector. So now James Chadwick incident alpha particles on beryllium foil. which basically cause the generation of ray 1, which were basically neutron, ray 1, which were further incident on the paraffin wax. And basically this paraffin wax then basically produce proton which were detected by a detector. Okay, basically these were hydrogen ions. Okay, so these were hydrogen ions. Now initially alpha particles were incident on a beryllium foil, so we can write equation like this: alpha particles, which are basically helium nuclei, He 2 into 4, they are basically, they give two neutron, two electrons. So these alpha particles are incident on beryllium. As you know that beryllium belong to second group of the periodic table. They are alkaline earth metal. Atomic number of helium is 4, and whereas atomic mass of helium is 9. So number of proton in a helium atom is basically, there are 2 proton in helium atom, and whereas there are basically uh, 2 neutrons in helium atom. And since helium is in a form of helium nuclei, so helium ion will have 0 electrons. So this is for helium. Whereas in case of beryllium, beryllium has basically beryllium has 4 electrons. It has 4 protons, and let me slightly clean it, and it has 5 neutrons. Okay, so this is for beryllium. So now when hydrogen, basically when helium nuclei interact with beryllium, then the basically due to interaction, the helium 2 protons combine with 4 proton of the 4 proton, which mean that the atomic number becomes 6. And you know that in a periodic table there is a specific element which has atomic number 6, which means that when alpha particles are incident with beryllium, beryllium is converted into carbon 6. Okay, or they are basically converted into a carbon, so carbon black, like this, when alpha particle is incident on beryllium atom. So now the atomic weight or atomic mass of carbon is 12. So now we have atomic mass is basically, it is a mass of a proton and neutron in a nucleus. So helium nuclei has 2 neutron and 2 proton, so 4 is here, and whereas beryllium has 4 proton and 5 neutrons, so this means 13 uh, is the atomic weight. But however, carbon has atomic weight 12. This means that there will be 1 extra neutrons. So the reaction of helium with beryllium basically produce a carbon atom, and with an energy in the form of rays, which is a neutron. The reaction in which 2 or more than 2 nuclei combine and form a stable nuclei is known as fusion reaction. So distant basically alpha particle when interact with beryllium they cause a fusion reaction, and due to fusion reaction beryllium is converted into carbon black, and it's release energy in a form of a neutron. So these rays ones are basically they are neutron, and these neutron when incident on the paraffin wax, the paraffin wax is basically cause the generation of the hydrogen ion, which are basically proton, which were detected by the detector. So the reaction in which one of the element is converted into another element is known as transmutation. Transmutation occurs when an energy or by any external force or by any external mean an element is converted into another element. So this is all about the experimental setup used by James Chadwick for the discovery of James Chadwick used the alpha particle scattering experiment, and on the basis of the alpha particle scattering experiment, James Chadwick discovered neutrons. According to James Chadwick experiment, James Chadwick used alpha particle source. He incident alpha particles on a thin file of beryllium, and the thin file basically generated radiations which were initially unknown. These unknown radiation basically when fall on the paraffin wax, they basically cause the generation of protons which were detected by a detector. The nature of these unknown rays were were explored by passing these rays through through positive and negative potential and or negative charge plate, but with that experiment it was observed that these rays has no deflection between the positive and negative charge plates. Furthermore, the nature of these rays were further validated by passing these rays through a magnet, and there was no deflection in magnet. On the basis of that, James Chadwick concluded that these rays are basically based on neutral charge particle, and these neutral particles are known as neutrons. These were further validated by James Chadwick by slightly modifying the Chadwick alpha particle scattering experiment. In the modification, James Chadwick basically replaces the paraffin wax. He removes the paraffin wax, and when the alpha particle incident on the beryllium file, James Chadwick observed that rays were produced, but these rays did not show any kind of deflection on the detector, which further confirmed that the rays one are basically neutral particle are known as neutrons. So this is all about the James Chadwick discovery of neutron. So thank you for watching this lecture.